an experimentation on how to connect these two batteries in parallel connection. Okay, so what is the importance of this connection? What is the aim of this experiment is we are going to learn how to connect these two batteries in parallel connection and how to improve the backup. Okay, for example, if you take already your battery, for example, what is the rating of this battery we have been selected? 40 Ah battery we selected. Okay, and let us take that it is taking some 4 hours to charge. How many hours? 4 hours to charge. Therefore, what is the amount of current? Current I is equal to 40 Ah divided by, I want current, you divide with time. What is this? 4 hour, 4 ones are 4 tens are. What is the maximum current it can supply? 10 amperes. So this battery can supply 10 amperes. This battery can supply 10 amperes. Resultantly, how much current they can supply? 20 amperes current. Basically, if you use one battery, it can supply how many hours? It can supply the backup? 4 hours. Single battery can supply for an electric vehicle or for a car. How many hours? 4 hours backup. So if you connect it parallel, what is going to happen? So it is going to increase 40 Ah plus this is how much? 40 Ah. Therefore, what is AH of the system? AH of the system is AH1 plus AH2, which is nothing but 40 plus 40 is how much? 80 AH divided by, or the time taken for charging? 4 hours. Therefore, the resultant current is how much? 20 amperes current it is supplying, and it is able to charge for how many hours? 8 hours. I mean, it is going to charge for 8 hours and give a backup of 8 hours. Previously, it was giving how much hours backup? If you use single battery, 4 hours. Are you able to understand? So, each battery you are taking T is equal to how many hours? 4 hours. Okay. Therefore, what is the time taken? I mean, what is the current taken by the each battery? So, the rating of the battery is 40 Ah divided by what is the time? 4 hours. What is the current of each battery? 10 ampere. Similarly, you calculate second battery T is equal to 4 hours and I is equal to 40 Ah divided by 4. Automatically, you are going to get 10 amperes. Okay. What is the resultant current of this system? When you connect them in parallel, current I is equal to I1 plus I2. Already we explained in the theory class. Okay. Therefore, 10 plus 10, how much current it is going to supply? 20 amperes current, extra current of 10 amperes it is supplying, and these two are connected in what? Series connect, I mean parallel connection. It is going to give a backup of 4 hours from one battery and 4 hours from another battery. We are going to increase the backup by 8 hours. That's what the importance of this connection of connecting the batteries in parallel. For example, you have a customer at electric vehicle or somewhere else. He's saying that I'm getting a backup only for 4 hours, and he's asking you as an electrical engineer, you increase this backup by one more 4 hours. Then how to connect the batteries? To connect them in parallel. How to connect them in parallel? Connect the positive to positive and negative to negative. Now we'll try to see the experimentation part for this. Okay, so see here. See here. So here we are going to have, here you are going to have battery. This is battery 1, this is battery 2. So this is nothing but which terminal? Negative terminal of the battery. This is which terminal of the battery? The next negative terminal of this another battery. Okay, you are having two batteries. Okay, next one, this is the positive terminal of one battery, this is the positive terminal of another battery. So I connected it 1 and 2. This is one set of battery. I connected it another set of batteries at 1 and 2 and 1 and 2. Now how to connect them in parallel? You know the diagram of parallel. What is the diagram of parallel? So when you have two batteries, take your circuit diagram. So when you have the batteries, okay, so this is the circuit diagram for connection. So see the circuit diagram for the connection. You are having how many batteries? Two batteries. So the positive terminal of the one battery is connected to the positive terminal of another battery. The negative terminal of one battery is connected to the negative terminal of another battery. I can say then they are connected in parallel. Now we have to exhibit this connection. Okay, so how to exhibit this connection? So see this connection. So this is this is the negative terminal. You can see this red black color wire. This is the negative terminal of first battery, and this is the negative terminal of second battery. So I'm going to short negative and negative by using this wire, this black color wire. I'm going to short this negative and this negative. And next one, this is the positive terminal of first battery. Okay, this is the positive terminal of which battery? Second battery. Positive positive I am going to short. Therefore, positive positive I shorted, negative negative I have shorted. This is nothing but I have been shorted like this. Okay, so when you draw it, you see here these two positives are joined at one point, these two negatives are joined at one point. So now we are going to get one resultant positive and resultant negative. So you are going to get a resultant positive and negative. You see here, this is the shorted wire. So from this you are going to get one resultant positive wire, from this you are going to get one resultant negative wire. So now coming to these batteries. Okay, already I told what is the rating of this battery. What is the rating of this battery? 40 Ah. Okay, sir, how this battery is? Okay, you see this physical battery. So this is nothing but you have one positive terminal, you have one negative terminal. What is the rating of this battery? Every battery will have voltage rating. What is the rating of this battery? 12 volts. And what, how to indicate the capacity of a battery? So you can see here the capacity of this battery is indicated here. What is that capacity? 40 Ah. Okay, the Ah capacity of this battery is 40 Ah. Okay, and I am going to have a one more battery which is nothing but positive terminal and negative terminal. Okay, what is the rating of this second battery? It is also supplying a voltage of 12 volts. And what is the capacity of this battery? 40 Ah. So now I have two 40 Ah batteries with voltage of how much? 12 volts. Okay, now you are saying that 12 volts, sir, what is this 12 volts? Okay, so you have a cell here. So you have internal cell 1, cell 2, cell 3, cell 4, cell 5. So this is nothing but cell 1. This is cell 1. Each cell will generate how much voltage? 2 volts. Okay, you see here 2 volts, 2 volts, 2 volts, 2, 2, 2. So now all these are connected in which connection? Series connection. This is of how much? 12. And you can see all are connected in series. Therefore, what is the resultant voltage? 2 into 6, where 2 volts is the each voltage of the each cell. So this will constitute one cell, this will constitute another cell, this is third cell, this is fourth cell, this is fifth cell, this is sixth cell. Each cell will generate how much voltage? 2 volts. So like that we connected all these 6 cells in series connection. Therefore 2 into 6 is going to generate a voltage of how much? 12 volts. Now what is the output of this battery? 12 volts. Okay, now let us try to check how much voltage it is going to generate. You see here, this is which terminal? Negative terminal. This is negative terminal of the battery and this is positive terminal of the battery. This is negative terminal of the battery and positive terminal of the battery. How much it is indicating?
12.56.
So this is negative and positive. How much voltage it is indicating? 12 volts. So this voltage is also same construction. Okay, so this is negative terminal and this is how much? Positive terminal. Now we connected both in parallel. And what is the voltage indicated in the battery? 12. Okay, so now this is 12 and 12. So for example, while you are doing this experimentation part or while you are testing these batteries at your house, one battery will indicate only 10 volts. 10 volts means you can come to an clarity that one cell is completely damaged. Okay, so how to check the damage? Okay, so you can see this this is called a specific gravity meter. Okay, so how to test the gravity whether the cell is healthy or damaged? Just you dip it inside and you just squeeze it up. Okay, you can see here this liquid you should not touch with your hand. Why? Because this H2SO4 this fully charged. So when you move it up, you can see here the float is showing how much value? 50 value. If it is 50 and it is nothing but below the red color button which is saying that this battery is good or healthy. Okay, so just squeeze it out again. So now battery is healthy or unhealthy? Healthy. If it indicated a red color, you can think that you require to fill with one cell is damaged or healthy, you can identify. If it's indicating red color, you can fix that one cell is damaged. So next, how to repair the cell is you fill with distilled water. Automatically the cell gets repaired if it's able to repair of its own. Okay, so that is how to check the water level in an each cell using a specific gravity meter. This is the first method of testing the battery before changing it. Next method is so this is called as a battery tester. This is called as an battery tester. So for generally, if you take this battery to the house or to if you take this battery to the shop, what they will claim is this battery is damaged. You go for a resale, and they will take this scrap for scrap, and they will pay you some 1,000 rupees, and on the new battery they will give you an discount of 1,000 rupees, and they will charge this battery, and they will buy this, they will sell this battery for higher cost. So they will not perform any load test. So that's why we have an meter called as a battery tester. So this battery tester will say whether this battery is really damaged or really healthy. Okay, sir, how to test this means just you hold this battery and you identify the negative. Where is the negative terminal? This is the negative terminal. You clamp to the negative terminal, and this one you clamp to the positive terminal. If it is a healthy battery, how much voltage it has to indicate? How much voltage? 12 volts. Why? Because 6 into 2. How much? 12. And in which color code it is existing? Green color. If it is there in green color means I can say the battery is healthy. So this is under no load condition. No load it is good. Whether it's able to perform on load or not also you have to verify. At the bottom you have an button. Just press that button. So when you press that button, meter will get heated up, and automatically you can see here once again it's indicating green. Indicates that battery is having a full capacity. It is used only 10% of its life cycle. Around 90% of life cycles are good. Why? Because you can see the color code. Which color? Green color. Green color is there means the health of the battery is good. So this is we concluded that this battery is healthy or damaged? Healthy in terms of voltage and in terms of its life cycles also. Now let's try to check the same battery. You have the negative terminal here and you have the positive terminal here. Okay, now we need to check the health of the battery. As soon as you connect, directly it will show the open circuit voltage. Or the open circuit voltage of the battery 12.5. It is good, well full charge. But under normal condition it can supply the voltage. But when you turn on the light, when you apply the load, it will not give backup. So in order to check it, we have this battery tester, and the bottom you just hold this switch for 1 second. That's all. So you can see here it is fully loaded and it is showing. When you hold it and it is showing which color? 90% it is good. 90% it is good, and it is set to charge. We have to charge this battery. Why? Because this is having a very less amount. You can see here the amount of heat produced on this coil. So it will get directly heated and it will show this. You see here. Now we have been disbanded. How much it is showing? 0 on red color. I mean, it is saying that if it is showing 0 volts, the battery is damaged. Okay, so this is how to identify the health of a battery with the help of battery tester. One day we'll try to have a demo on this battery tester, how to use and what is the advantages of this battery tester. So now by using our equipment in the lab, we tested the health of battery 1 and battery 2. What is the voltage of this battery? 12 volts. What is the voltage rating of this battery? 12 volts. What is the health of the battery? Good. What is the condition of this one? This is also good. So now we are going to connect them in parallel and we are going to load the equipment. Okay, so this is about all about battery. So suddenly now you learn how to use the battery after charging it. Okay, so now let us try to see here how to charge the battery. This is called as a battery charger. This is called as an battery charger. Just have to give the supply. Okay, and as soon as you give the supply, you have to connect this to the positive terminal. Okay, so this is nothing but the positive terminal and this is nothing but the negative terminal. Okay, so you can see here the modes of operation. This is an Bosch C7 model battery charger. So you can see here what it is showing. The battery is getting charged from, it is low percent and the battery is getting to fully charged. So now the battery is in the case of what? Charging. So now this charger is converting AC supply to DC supply and it is charging our battery, and it has shown that this is having only 90% of life. So now if you charge it full, automatically it can give the required voltage. So now just we are charging the battery. Okay, so this is how to charge the battery. So this battery comes under the classification called as a constant current and constant voltage. Okay, so you have two types of chargers. One is constant voltage charges and constant current, and next you have hybrid. So this will exhibit generally constant voltage and variable current. Okay, so it can exhibit two types of charging methods. Okay, so generally we buy the mobile phones, what you have is constant voltage charges. Constant voltage charges, in that depending upon your state of charging, 0 to 90% it will give more current, 90 to 100% it will give low current. That's why the time taken to charge from 90 to 100% is very less, and 90 to 100 it will perform slow charging, and 0 to 90 it will perform fast charging. You are very clear about that mechanism, that everything will be done by this constant current chargers. Okay, so this is about the everything about battery. Okay, so this is basically, so generally for layman, we have battery tester. Generally those are more technical. They will test the health of a battery with the help of an battery tester, but the manufacturer will specify like this. You can see here, if the battery is good, see here, if the battery is good, which color it will indicate? Green color. So you have to see from this side, and you can see here the color indicated in the battery is what? Green color. So you have an window inside, which is a mirror window. If you look inside, it has to show which color? Green color. So come and see here which color it is showing. Which color it is inside it is showing? Green color. Okay, so if it is a green color, if it is showing, you see here battery is okay, means if you see inside this eye, it will show green color. There's no need to bring to a technician. Inside you can see that this is in which color? Green color. Okay, now both the batteries are in healthy condition, both the batteries are in fully charged condition. Okay, and now we are going to connect these batteries in which connection now? Parallel connection. Okay, coming to the parallel connection, I already explained these are two negatives, I joined two negatives. These are two positives, I joined two positive. Now coming to your circuit diagram. Okay, so circuit diagram as wise we are going to give the connections. Now you connected these two batteries. So when you join these two batteries, voltage is same or voltage is different? In a parallel, what is constant? Voltage is constant. What is the voltage of this each battery? 12 volts. This voltmeter has to indicate how much voltage? 12 volts. Okay, so here we are going to indicate, we are going to connect this voltmeter in parallel. Okay, I will explain the connections. So you see here, so from there you have taken one positive wire and negative wire, and we had given a basic protection. Okay, we had given a basic protection. So this is basic fuse protection. Unfortunately, for example, you shorted this rheostat, this meters and this battery will damage. This should not occur, means we should isolate, I mean should isolate or you should perform open circuit. So that's called basic KitKat fuse. Okay, so how much is the current which is flowing into our circuit as per the design we had made? How much is the current? So one battery, what is the rating of the battery? 40 Ah, and we have taken how many hours to charge? 4 hours. Okay, so or you take it is taking some 10 hours to charge. Then how much amount of current? Maximum 4 amperes. This battery is supplying 4 amperes, but for a given time of how many hours? 10 hours. Are you able to understand or not? A 40 Ah battery can perform two works. What are those works? Means it can supply 4 ampere current for a time of 10 hours, or it can supply 40 amperes current for a time of 1 hour, or it can supply 4 ampere, I mean 4 hours backup for a time of 10 hours. It can supply 10 hours for a time of 4 hours, 10 into 4, 40 Ah, or it can supply 4 amperes current for a time of time taken to charge is how much? 10 hours. Okay, so like this also it can supply, or it can supply 40 amperes into an time of 1 hour. Also it can perform. It depends upon how you load that equipment, how much amount of current you load. Based on that, the backup is going to change. So now in order to understand this example, I am taking here the time taken by these batteries to charge is 10 hours, and automatic how much is the current? 4 amperes current. Okay, so here you are getting 4 amperes, and from here you are going to get 4 amperes. Okay, so totally 4 plus 4 is how much? 4 plus 4 is 8 amperes. So 8 is 100% load. So due to short circuit or due to internal problems, we are increasing the battery capacity with 1.25 times. Multiply 8 into 1.25 times. 8 into 1.25. So 8 is 8. 8 into 0.25. How much? So approximately you are going to get 10 amperes. Okay, so now we are designing this fuse. You can see here how many leads are there. You are having lead 1 and lead 2. Here 2 leads are there. Each lead will carry a current of 5 amperes. That made it in parallel. How much current it can carry? 10 amperes current. That's how we designed this basic fuse rating. Okay, so what is the fuse rating for this? 10 amperes. Okay, so we are keeping this fuse rating. So you may ask, sir, already safety you design, no. Why you have been gone for one more safety? This is primary safety, this is secondary safety. The cost of this experiment is approximately 50,000. Is approximately 50,000. We want to do some electrical protection in the help of a basic fuse, and next one is MCB, miniature circuit breaker. So this is like a manual fuse. This is like an manual KitKat fuse. You can remove it. If it blows off, you have to replace with an reviable fuse. So you can select the current rating 5 amperes fuse, 10 amperes fuse, or if you have only one 5 ampere, then you connect them in parallel. If you connect them in parallel, how much the current is increased? 10 amperes. The same methodology I used. If I use one lead, it will carry how many amperes? 5 amperes. If I use two leads, they are connected in parallel. In parallel connection, what will happen? Current will increase. So maximum current it can withstand is 10 amperes. Okay. So this one is like automatic fuse. If any problem occurs, automatically this will fall down like this. For example, if it short circuited, automatically it will drop like this. And again, what you have to do? You should push it up. Automatically the fuse is wired. So this is called which fuse? Manual fuse. This is called automatic fuse. Okay. So now I am fixing this fuse, and what is the current rating we identified? 10 amperes. Okay. So this also we are designing in the range of 10 amperes. We are little bit increasing it, going to 15 amperes. Okay. So this is C 20 amperes. For example, if a dead short circuit also, first this will blow. If this is not blowing, automatically this will blow. This will be the lower rating, first this will blow. If it's not blowing, automatically the higher rating will blow. Any cost, our equipment should not damage. That's what the intention of the experimentation part.